Yeah, hello. So this is just a short video to show how to model an oblique impact on a composite plate. So this here, first, this is the simpler case when you simply have a plate and then the projectile is impacting it head on. But what we want is that we want the impact to happen at an inclination, which is also known as obliquity. So we want the bullet to hit at an angle, let's say 30 degree. So I'll just show you quickly how to model this. So this is just the basic model. So once this is ready, what you want to do, go to assembly, then open rotate instance. So when you click this, you'll have to select the instance you want to rotate. So what you can do is you can rotate the bullet or the plate. But if you rotate the bullet, the problem is when you define the velocity, you have to give the axis along which the velocity you are inputting. So it's better you rotate the plate so that the input velocity will have the same axis, that is z direction in this instance. So let's rotate the plate. So we'll select about which 2 points we are rotating. So one is this one, the other is this one. Let me show. So these two midpoints facing the bullet. Okay, so what's the angle of rotation? So we are taking 30 degree, press enter. So there you go. So that's it. All you need to do is rotate the plate. But the thing is, you have to check carefully. This, yeah. So as you can see, the bullet and the plate are intersecting. So what we have to do is move the bullet towards left side, so that when we mesh and we start the whole process, they are not intersecting each other. So for this, what you can do, go to the create datum points, hold and select with the left key, and click on create offset. So for creating offset, we click on the reference point which you selected at the tip of the bullet, click on it, and by write the coordinates by how much you want to shift. So as you can see, this direction is z in the z axis. So in the z axis, let's move it 0.01. Okay, so I think it's too much. 0.01. Let's move 0.00. 0.01. Okay, oh, sorry. So we have to move it in the minus z direction. That's why it's going over there. So once again, we click on it, reference point, minus 0.01. So yeah, this is the reference datum point we have created. All we have to do is move the whole bullet from this to this point. For this, we simply use the translate instance. We select the bullet because we have to move the bullet. Then we select the reference point, and then the new point we have, offset point we have created. There you go. Done. So as you can see, so at an angle, we can use this method. But what if, let me show you another example. Let me open a new file quickly. Yeah, let's not. So this is another example I have. So this is a honeycomb. So this is honeycomb, and it has front and back plates of composites. So this is known as a sandwich panel, you can say, because there are other panels around, and it's a sandwich of like a honeycomb and two plates. And once you have set up this model, you have to tie each point. Let me show you real quick. So you can see all the points. So the plate is tied to the honeycomb. So what in this case, if we want to hit the projectile at an angle and we tilt the whole panel by 60 degree, it won't go together, because let's say you select the plate will move 30 degree, then you will move the honeycomb, and then you will move the back plate. So again you will have to select all the tie points. So a more useful way here would be just to use the vector of the impact velocity. So like, let's say we are using 3 meter per second and we want the angle of obliquity to be 30 degrees. So we can simply, so in this direction, in this case, which is the y direction, what we can do is 3 sine 30 1.5 and 3 cos 30 2.58, so that we get a resultant motion of 3 meter per second in 30 degrees. So simply just go to load, predefined field manager, edit, or if you want to create, just create, or I've already created, so I'll just edit it. So there you go. So in the y direction, that is v2, it was 1.5, while in v3 it was 2.598. What you have to take care is that this is in the positive direction, sorry, this is in the negative direction, right? So negative direction for the z axis, while positive for the y axis. Yeah. Okay. So next is, we'll just move the bullet at a 30-degree angle so that the bullet travels the way we want it to. So let's open assembly, and then once again we'll rotate the instance by 30 degree. Sorry. Yep. So if you want to rotate the instance, click on rotate, select the bullet, then you have to select the points, 2 points, along which you have to rotate. So along this line we'll rotate 30 degree upwards. So we select this point and we select this point and we click 30, hit 30, and that's it. So it's 30 upwards. But if you see from the side, the bullet will impact over here, but we want it to impact in the center. So but before that, I think if we move it to here, it will intersect with the plate. So let me just again create an offset. I'll click on the reference point which I had before only, and let me in negative 0.01. This in the plus direction only, no worries. It again 0.01, enter. So this is the new offset that datum we have created. Now let's just move the bullet over here. So click on translate instance. Okay, so I didn't click OK then. Let me just rotate it quickly. Done. 30, enter. Position of instance. Okay, this is final. Now let's move it. Move this instance. Done. From move the reference point to this new point. There you go. Okay, done. So as you can see, we have created the same thing, but instead of moving the plate here, we have moved the bullet, and at a 30-degree angle only. But because we have set the load, as you remember, we have set the load in a vector form. So in plus y it's 1.5, and in minus z, it's 2.598. So the resultant velocity along this line, this dotted yellow line, will be 3 only. So this is also a way we can model obliquity or projectile hitting a plate at an angle of inclination. So I have the, so we can just complete the all the modeling and run the job. To save time, I have the completed, yeah, I have the completed ODB file. Let me just open it. There you go. And let me just show the contours. Yeah, let me just run it. You can see it's moving in the 3 meter per second is along the line which we want to. So that's it from my side. Thank you.